Okay, it's 11:30 and I want to welcome everyone to this webinar about smart connectivity for forestry and livestock transport. So today we have Per Jonny Nesse from Telenor presenting some forestry operations connected, and we have Michael Nurremark who's going to talk about livestock transport and some digital solutions for that. So welcome very much, and I will first just give you some short presentation about the COMMECT project. So next slide, please. So we just have some housekeeping rules. So please mute yourself when you're joining here, and you can keep your camera off because we're going to record this webinar and we will publish it on our website and social media. And we will take the Q&A, so questions and answers, after the presentations. And we have a special function for the Q&A. So please use this Q&A function, and then we can keep track of your questions in a good way. And if you want to, you can raise your hand during the Q&A session if you want to speak up and be recorded on the video. Next slide. So COMMECT, just for you who are new to the project, it's a European Horizon project and a research and innovation action. It's a 3-year project. We have 6 months left of the project, so we're coming to the final of it, and it will end here in August. Next slide. And the project is about the digital divide, we call it, that many rural areas or remote areas around Europe and beyond Europe too are unconnected, and there's becoming this big divide between the rural and the more urban cities, where connectivity in the urban areas are much more common, but the rural areas do not have as good connectivity solutions. So we need the connectivity so that we can go towards a digital transition. Next slide. And in this project, we have 5 living labs. We have 1 in Luxembourg with focusing on viticulture. We have then 1 in Norway that we're going to learn more about today, connected forestry. We have 1 in Denmark, which we're also going to learn more about today, about connected livestock. And then we have Turkey with smart olive tree farming, and Serbia about sustainable agriculture. Next slide. So these different living labs have different solutions and different focuses. So the one we're going to focus on today, the Norwegian one, is about the forestry and the situational awareness, but also how you can use remote support. And then we're also going to learn about the livestock transport from the Danish living lab, how you can monitor transport on the road, but also unloading and loading this livestock. Next slide. And we have different types of connectivity solutions that we can use. We can use Internet of Things, or in Norway, they use 5G private networks, for example, and UAVs and some different types of satellite backhauling. Next. So I'll give the word over to Michael Nurremark from Aarhus University to take over from here.
Thank you, Gabriel, for the introduction. So my name is Michael Nørremark. I'm from Aarhus University, the Department of Electrical and Computer Engineering, where we work with connectivity solutions, but also machine learning and other interesting things, and also precision farming and data science and all kinds of software and computer and electronic engineering. And I will give you a short introduction to what we have done so far in the COMMECT project in relation to this livestock transport that we call connected livestock transport. So next slide, please. So livestock transport in Denmark is quite a big business. So we are exporting almost 15 million small pigs every year to both in European countries and also in the very neighboring non-European countries. And as you can also see that 60% of all these pigs exported around EU and outside EU, they are originated from Denmark. So yeah, we are producing a lot of pigs. Yeah, and each of these loads, you can see some pictures to the right where they are gathering the pigs onto a truck, and they are also washing a truck. You can see the compartment, what I call compartment. That is where the pigs are located doing transport. And there are about 500 to 700 pigs on such a load when they are weighing these about 30 kilograms. And then there are some regulations, of course. There's a lot of issues with animal welfare, but also control of disease or avoiding disease spreading and so on. So, for example, there's this maximum travel time is 24 hours. Then they have to rest. The pigs have to rest for 24 hours. And of course, there are many other regulations as well. I will come back to that. And one of our partners here in the project is Padborg Transport Center. And at this transport center, there is a washing and disinfection place. And when the trucks are entering Denmark, that's very close to the German border, or it's actually on the German border between Denmark and Germany. There's 92% of all the trucks that are transporting animals, they are being washed and disinfected and checked, inspected in Padborg. Yeah, about pig farming in Denmark, there are many employees in the pig breeding industry directly employed. And of course, the pig farming also have a lot of impact on the local society, on the rural areas, in terms of services, transport, and manufacturing, and so on. Yeah, next slide, please. Yeah, so this is what we call the value chain and the processes of livestock. So I will just go through it very, very briefly. In the middle, we have the operations center and fleet manager. That is typically the pig trading company. They are following all the trucks and have to make sure that everything is according to plan. It is actually the regulation that you need to know where these livestock trucks are at the moment and what different temperatures and other things to monitor the health of the animals and so on. So in the very center of this, we have the operations center, and then it actually when a load is going to start, we are starting with the washing and disinfection, and then there are some quarantines, and then it will pass on to the farm and pick up the pigs and drive on. And as you can see with the symbols, we have some satellite icons. That means we have to locate the truck every time. We also have an icon called 5G, illustrating that we need connection. We need data transmission. So these dotted arrows you see going to the operation center, that is actually a need for connectivity, a need for transmission all the time. So this is just the process, and it's just going around following the thick arrows. You can see it's just going around in a circle. So the driving is of course very much depending on the outside temperature. There are regulations in terms of below 5 degrees. It's not allowed to drive the pigs. Above 25, I think it is, it's not allowed to drive with pigs. So So it can be stopped, this process, of course. So there are some periods of the year where they are not transporting pigs. So next slide, please. So in the project, we have asked a lot of stakeholders that are involved in livestock transport, all the way from the farmers to the trading company, and also the companies or the manufacturers of trailers and logistic tools and other things related to this. And also there are a lot of organizations involved in this livestock transport. We asked them what are their user needs, and we found out that coverage, that is seamless connectivity, was one of the issues they are dealing with. So we could look into that. And also some digital tools that they would like doing the unloading and loading of livestock, and also the route optimization. I will come back to all these solutions that we came up with. So we determined, or we described 3 use cases that we will work with in the project in terms of connectivity solutions and digital solution, and that were monitoring of livestock transport along the rural roads and license plate recognition. That's also very important to allow only the trucks with the right certificate, that in terms of disease status, that it is having the right certificate, and then it can be allowed to enter the farm for loading pigs or unloading pigs as well. And then the last one, which is the one that is consisting of a lot of AI and edge computing, perhaps, or some other stuff that were mentioned in the beginning, that is monitoring of the livestock during the loading and unloading process. So next slide, please. And here's just a list of all the stakeholders that we have been in touch with and who has an influence on this trading business, pig trading business. So you can see there are some organizations and some authorities and farmers and truck drivers and also the suppliers of digital solutions for the trucks and trailers. So yeah, and then also manufacturers of animal feeding technologies came into they actually contacted the Living Lab because they also have these issues with a need for seamless connectivity when they are online with their feeding systems on the farms. So yeah, next slide, please. Yeah, just maybe some of you know that there is actually a new EU regulation on its way for making some rules for this livestock transport. So it's replacing a 20-year-old regulation, and actually there's been some work in the EU to come up with what can actually be modernized, or what can we actually do. And one of these reports that we have found is that something like advanced intelligent transport systems, ITS, and cloud platforms for this transportation sector could actually improve this kind of transport, or this transport sector of livestock. So there is a lot of focus on this, both politically, but also in the businesses, of course. And everything comes down to animal welfare, of course. Yeah. Next, please. And yeah, so one of the digital solutions and also connectivity solution is, of course, this with the covers, the seamless connectivity. And here in the project, we have tried different things and we have tested it. And something that Aalborg University, our partner here in the Living Lab, is working with is called multi-connectivity. And we have done some tests. We have followed a livestock transport route, and we are looking into if this multi-connectivity can actually improve this. And I think the preliminary results is that it can actually improve seamless connectivity in rural areas. So and it's very important for for sharing the data from the trucks. There are temperature sensors, sometimes there are CO2 sensors as well, to make sure that there is the right temperature for the pigs on board. And also it is also regulation that you have to share the location of the trucks every 15 minutes to 30 minutes, but you have to upload data wherever you are. That is actually because we have to know where the truck has actually visited because of this disease spreading, and also that it's not exceeding these 24 hours of transport. Next slide, please. And ITS, intelligent transport systems, is actually something that is very much companies are working with this to make traffic much more safe and also inform about accidents. But you can see to the left, this is just a diagram of what research and companies are working with in what's called traditional ITS. But then you can add at least 5 more input factors or factors that has to be implemented with this ITS. And that is again with the temperature and ventilation and health, and actually other hauling companies doing temperature control, transport of goods. They're also very interested in this ITS, of course. And then we have for the livestock, we have the driving and resting for all truck drivers actually. Where should they park, especially when they have animals on board? Where should they park for the drivers resting and for the animals resting and so on? We should avoid the disease contamination, and quarantine certification is important to have on board. And what you can see to the right is that we have a map. It's right, the map how it looks like yesterday. So all the black areas are areas in Europe where the trucks with livestock have to avoid driving, and all the purple or red area is where there's also a risk. So you have to avoid all the red and black areas when you're making your route. Yeah. Next slide, please. And this is just an example of how this certification and quarantine is being registered. So there is a log file to the right where data has been logged from the truck, and you can see it has been driving for, sorry, it's in Danish, but driving time is 20.8 hours. So that's fine, and you can see how many kilometers and so on and so on. So that is the kind of report that every truck has to make when it's doing livestock transport. And behind this and in this database, temperature logging and other things, opening and closing of the ramp for the trailer is also logged, and so on, so on, so on. And to the left, you have this certificate for each of the truck and trailers that is also registered online. That's the database that should be used for example, letting the trucks enter the farms, allowing them. So if they have a red, as you can see here, this example is red. So this truck is not allowed to enter any farm in Denmark for the time being. So next slide, please. And the other use cases, we had 2 and 3, which was about, as you can see in the figure, about this gate at the farm that we have to get online to access this database for the certificate. So the truck I mentioned before with the red status will not be allowed. So the gate will be closed, even though that the truck is parked just in front of the gate. It will not be allowed to enter. We need connectivity for that. There's a company in Denmark working with this kind of gate and camera system, and they are making all their image processing and so on in the cloud. So it's typically a cloud system. So they would definitely like some higher data rates and low latency in rural areas for their support to farmers in that sense. And the other thing is to the right with cameras again, and that's where the machine learning and computer vision and everything is involved. Again, some companies are asking for cloud setup for this, and other are using edge computing. But we have to service both of these kinds of companies, of course. And this is about inspection of the pigs. And you can see there's also a camera on the farm. So a good idea is to actually register a lot of things about the health of the pigs, the weight, the fitness for transport, and other things when they are in the pig farm, because then the farmers can sort the pigs before they are entering the trucks. Today, everything is done during the loading of the trucks, and it's the driver who is looking at the pigs and inspecting them and saying that, no, this pig is not ready for or not fit for transport, you should take it back. And this is we really need automation for this. It will save a lot of time and money, and worst of all is actually there are pigs that are being destroyed as soon as they are outside the stables and they are not going on the truck. They have to be destroyed or killed. That's really we have to do something, definitely, and everybody agrees to that. So next slide, please. This is just two commercial examples of camera systems in the stable. To the left, we have Pixel from Sweden. What you can see is that just above the blue box, there is a connection to the internet. So all these cameras, and we calculated that on an average sow farm in Denmark with 675 sows, we will need 135 cameras in the stables. That's a lot, but everything else is actually also costly for a pig farm. So our take on this is that it's not a big extra expense to put up 135 cameras in these stables for the piglets. To the right, it's a Danish company, Skov AS, who's also making camera for the pig stables. And both of these systems, both from Skov and Pixel, they are at the moment only used for estimating weight of the pigs, nothing else, nothing about health status or injuries or fitness for transport or anything. So, but they can only estimate weight. Next slide, please. So in research, there are many examples of where they have taken this computer vision and machine learning into a higher level. So this is just examples of images of pigs in a pen, where you can see they're also identifying that it's lying down, it's standing, it's drinking, and also the ID of the pig. That is also very important for the inspection, that we can actually recognize where do these pigs actually originate from. So that's why we think that the science behind this and the engineering behind this is actually there. We just have to apply it to this with the livestock transport sector. So this was just an example that it's actually possible to make use of computer vision and artificial intelligence to recognize the individual pigs and their health status and everything, and also the weight, as I mentioned before. Next slide, please. So this is my last slide. This is just some of the what we can provide from what we have obtained so far. There's a lot about connectivity. For example, we would definitely like to tell our stakeholders, especially the ones developing logistic tools and digital solutions to the truck industry and to the farm pig farm industry, that is actually possible to improve the seamless connectivity by looking into novel connectivity solutions like multi-connectivity. And another thing is about this local 5G that we have tested on a Dutch pig farm. That's it's actually possible to do the upload of video on a good level for this kind of computer vision and machine learning algorithms in the cloud for the future. So that's what we. So now the connectivity at least is in place, and we are having some scientific papers pending on these results, but we are definitely going to share these results that we have and also try to train the stakeholders, which are mainly the hauling and manufacturing sectors, in these new connectivity solutions. And then, of course, we would like to work together with them to also research and develop these digital solutions that, as mentioned before, with the ITS and the recognition of the pig's health and weight and ID and fitness for transport in the stables before they are loaded. That's definitely some of the initiatives that we will take in the Living Lab. So please, next slide. That's my last. Next. So thank you very much for your attention. This is just some pictures from the Living Lab in Denmark, where there are pictures of pigs, and then there are pics of some humans. So we have gathered some people in this Living Lab, of course, to sort out all this. Yeah. But thank you very much.
Thank you, Michael. We will let Per Nesse from Telenor continue with the forestry and remote forestry operations. Go ahead. You're muted now, Per. Let's see.
Yeah, okay. So my name is Per Nesse, and I come from Telenor Research and Innovation, which is a small department within the telecom operator named Telenor, as you may are familiar with. We are roughly 35 people working on AI and next generation network technologies. We are heavily engaged in a lot of EU research and development projects, and the COMMECT project is one of these. And I will now introduce a little bit on the background and on the solution that we have been trialing out for the forestry industry. I will also show a small video of a lab pilot that we have been performing. So let me see. So a little bit about the background about the forestry. In Norway, roughly 40% of the country is covered with forest. A lot of these forests, the trees are productive, almost 70%. And there's also a high number of trees being planted every year. And in 2021, it was roughly 40 million trees planted. It's also important to note that roughly 50% of the endangered species are found in forest. So having a sustainable forestry industry has to also rely on saving these species. There's a challenge that the public MNO networks in the forest areas are limited, and this is also the case for 5G. And for our trial or pilot and Living Lab in Norway, it's especially the case because we are focusing on an area called the Innlandet County, which you see in the picture to the right. It's close to the border of Sweden, and in this area there is a lack of that type of coverage. It's also important to say that although the forestry industry is not as large as oil industry and other industries in Norway, the forestry industry is quite large compared to our neighbor countries in Sweden and Finland. And from a telecom operator point of view, this is very interesting because Telenor has a footprints also in these countries. For the operator, it's very challenging to perform the operations today. The decision-making process is quite complex, and there is a kind of a demand that each operator sitting in the forest machines, cutting down or logging trees, are expected to log roughly 150 trees per hour, and that's quite a large amount of trees being logged. And solutions to advise and to help these operators are looked upon as necessary, and this is something that we find from interviews in the industry. The industry is also characterized with a low degree of digitalization and innovation. There are a number of work accidents. It's very male-dominated, and there are recruitment issues also present. And finally, they are struggling with increasing the demands for more sustainable operations. So in this living lab, as in the other living labs in COMMECT, we have been working in a very agile way. So we have kind of started to talk with the different stakeholders. What is your problem? How are you doing things today? What is the as-is situation? And through these interviews, we have been collecting needs and requirements for potential solutions. And then we have been developing solutions, proof of concepts, type of prototypes, and doing tests of them. And in these tests, we have also involved the stakeholders to a high degree. Following the next step in our process is then to validate what kind of impact are the stakeholders expecting from these solutions. So I will also come back with a quick quick feedback that we have been gathering so far, although we are working on still a more comprehensive way of gathering these data related to socioeconomic and environmental impact also from the solutions being implemented. And finally, we need to look for models to work under with respect to commercializing the solutions. And this is the final step in our working process. So in short, the value chain in the forestry industry takes roughly 60 to 80 years. You start with the planting, you do the care of the forest, then you thin out the trees that are not expected to stay there, to give room for the trees that you then later would like to log. And then it's the transport to the sawmills, and then it's the further processing. So in our studies, we have been identifying the needs and the most vital needs within the industry, and it seems that having a digital assistance of the operators in the forest is one important need. And the other one is to handle more complex situations as related to fire, and also to monitor the health of the forest. In this case, I would like just to focus, in this presentation, I would like to focus mostly on the digital assistance or the remote assistance of the forest operator in the further slides. As mentioned, the connectivity, enhanced connectivity in the forest is a challenge. As also mentioned, the digitalization and the certification of the operation related to CO2 emissions and health and safety. So different stakeholder groups have been involved, technology solution providers, forestry machine operators, forestry owner associations, forestry machine vendors, and insurance companies, all together helping us to provide a good insight into what is the challenge for the industry. So as a mitigation of the challenge of having connectivity into forest, we have introduced a private network solution which we call Network on Wheels. And this is something we have been introducing to help implement the digital solutions for the operator. So the 5G private network on wheels, it facilitates a seamless remote support through online cameras, and these cameras had in this case been provided through Nokia. So the experts from the forest operators company could then remotely advise and assist on-site operators in their decision making throughout the day. So furthermore, the same solution could also, the digital remotely solution could also address the maintenance, let's say, of John Deere from the John Deere support service operators for the detection and the repair of engine and machine errors. So in this case, also the vendor's expert could supervise the operators through the online camera solution, which has a high quality video feed at the vendor's location. Moreover, this Network on Wheels solution is a self-contained entity. It encompasses the 5G radio, 5G core, and ancillary applications within a singular, effortlessly transportable mobile network. So it provides a complete standalone 5G network, private network that can be set up quickly and provides 5G coverage. So the node traffic is then backhauled either via terrestrial network or via satellite, depending on the need and the location. And to provide real-time forest monitoring and surveillance for situational awareness, which was also one of the use cases. The Network on Wheels edge server can be equipped with AI and ML algorithms for efficient detection or any unwanted incidents like forest fires and other anomalies. So this machine is then trailer is then powered by a battery unit that provides a backup energy backup for around 2 hours. The batteries can also be charged on the field with an external gasoline generator. We have been performing some experiments, as mentioned, and in this case, the Network on Wheel was placed in a selected location in the forest, and then the uplink throughput was measured with a smartphone for locations deep in the very dense forest, as you can see from the picture on the left side. So the tests were performed using 80 megahertz bandwidth in the 3,300-3,400 megahertz frequency band, and the transmit power was set to 35 decibel milliwatts with antenna height of 2.5 meter. And with this kind of configuration and setup, we achieved an average uplink throughput of around 10 megabit per second, which we, even at a distance of 300 meters, which is shown in the picture. And this is this is sufficient for performing the online remote solution that we presented. Yeah. So we did first we did before we did this test in the forest, we performed a lab trial simulating this setup, and this was done at the headquarters at Fornebu, at Telenor's headquarters in Oslo, Fornebu, Oslo. And as you can see, there are some some trees behind the forest facilities here, the offices. So we placed one operator marked blue as an expert, and the other was sitting inside a car, driving on the green area, as you can see. And we placed the antenna in the car, and also with the camera using the smartphone. And I will show you a video of this test in the following slide. Remote expert supervision of forestry operations mitigates the challenges of rapid and complex decision-making in respect to logging, repair maintenance of forest machines, and navigation in proximity of protected areas with rare biotopes and cultural monuments. In this demo, a car simulates a forest machine, and the expert remotely located is provided with a 360 degrees camera real-time view from the forest machine operator surroundings using Nokia's RX-RM solution. The real-time extended reality multimedia RX-RM solution is a software connected into a computer display and/or VR glasses. It encodes video and 3D spatial audio from the camera.
We lost sound here now, Pat. Maybe you turn your mic on again.
Employee safety and more environmentally friendly operations compared to conventional practices. Okay, I understood there was some challenges with the sound, but the video tried to explain how we kind of tried out the solution in a lab setting using this camera solution where we from Nokia, where we transmitted real-time pictures and live videos from the car, in this case in the forest, back to the expert. We also did a similar test out in the field, and this is and the results that I mentioned related to the coverage length was gathered from this pilot. Of course, we were very curious on whether this the solution that we introduced would actually make an impact for and support the challenges and the needs which the stakeholders had expressed initially. So what we did is that we have developed an online survey solution for the different stakeholders to respond to the questions and express their degree, the expected degree of impact from having the solutions back to us. So this was an online survey. We introduced pictures, we introduced text, and we introduced videos of the solution. And then we asked them questions related to what kind of company they were coming from, and whether they could, on a scale from 1 to 6, report back whether it was expected a low degree, a medium, or high degree of impact with respect to economy, environmental, sustainability, etc., for applying these solutions. And so far we have gathered, we are working on this online survey, but we have already gathered some results from a pre-test, from a pre-test of some of the stakeholders before launching it to a wider audience. And as you can see on the left-hand side here, the preliminary findings is that the stakeholders see the solution as a way to decrease cost and time of their operation, maybe also to increase profit, but also with respect to community goodwill and improve the user experience. So there are some potentially good results from actually applying these solutions in the operational settings. So the final solutions then, the final steps, both for the forestry use case or living lab, as well as for the livestock living lab, is now to finalize the impact assessment based on the tests that have been performed, and is also to look for a business setting together with partners, and going forward with exploiting and commercializing the solutions that we have been trialing out so far. And this completes my presentation of the forestry use case. So thank you very much.
Thank you very much, Per, for a nice presentation. If you have any questions, you can go to the Q&A tab on top of Teams here and post a question, or if you want to raise your hand and get your voice recorded, you can also do it that way.
Could I add a little comment maybe?
Yes.
So just for your information, we believe that, talking for the forestry industry, we definitely believe that this digital forestry solution is applicable also beyond the forestry industry. So we see that it's applicable for industries such as mining and agricultural machine operators for remote operation of their activities. But we also see that the solution can assist in use cases within inside factory buildings. So especially for forklift drivers inside dusty industry buildings, this is kind of areas that we already are looking on for seeing beyond the forestry industry itself. So this is important to say for the forest industry. I think also it could be similar for the livestock and for other living labs in the COMMECT project. Thank you.
Thanks, Per. While we wait for any more questions, I can start with a question for Michael. You talked about these cameras that can help detect and help load and unload these livestock, and perhaps detect some of the issues with the animals that have to be fit for transport. Do you think these cameras will be better than humans, or a complement, or how should we see this technology? Will they be better? Can they detect as much? I mean, maybe a human can feel the animal a little bit more, but cameras are maybe better on other things. So what do you think?
I've seen just an example of how accurate it is. For example, this PIX axle camera system for the weighing of the pigs. it's the test they've done is and reporting is actually about ±2 kilograms of a pig that is weighing about 100 kilograms. So it's pretty accurate actually, using this kind of machine vision systems. So I believe definitely that it is possible in the future to both to recognize the individual pigs, because that is also a human task, that is to identify where the pigs actually originate from when the veterinarians are doing these inspections of the loads. So yes, there are so many things that the humans, the driver, the veterinarians, the farmers' employees have to be aware of before they actually enter the truck. As soon as they're on board the truck, this is point of no return. The pig's on board, and if the truck driver has been stopped somewhere, or there's an inspection, the fees or the fine are very, very big if there is a pig on board that is actually not fit for transport. So yes, I definitely believe that these machine vision systems will be better than all these different humans involved in this process. So yes, I believe it will be better, and then you also have somewhere to you can also track. So if there is a mistake happens, you can follow it. You can follow it all the way to when the pig was entering in the pen inside the stable. You can follow this pig all the time. You can see where did it actually go wrong? Why was this pig on board the truck, and so on. So you can also use it for traceability, of course. In that sense, it's also avoiding human error another time. So yes, it definitely improve and eliminate human errors. Yes.
Thank you. Still waiting for some questions in the Q&A. So while we wait, I'll continue with our question for Per. You talked about these private 5G networks in the forestry. What are the challenges there? Is it technical issues, or is it about the business model, investments, cost, coverage?
I think we haven't. We are still working now on developing a business model, because you can find cameras that are really premium cameras, pretty expensive, and you can find less expensive cameras. We also see that, and I think this is a situation for in many similar cases. You also see that you need partners to support you in developing a commercial solution. So it's about finding the correct partner, helping us to enable a commercial solution. Telenor, as an operator, are very good on connectivity, but maybe there is a need for a company that knows and is very familiar with the vertical to support us in this work. But of course, it's about we did a lot of experimentation and testing for when introducing this forestry, this 5G on wheels, of course. So there is a need for more feasibility studies as well. So both technical and financial challenges going ahead. I just wanted to, if I may, I just wanted to add on that people make errors, also in the forestry industry. And there has been a lot of attention now lately in Norway that forestry operators cut down trees with burn nests, and they get a heavy penalty for doing this. So it's about introducing digital solutions that also can hinder these human errors. this is important to facilitate as well. Beyond also, of course, supporting the cutting down, making the operations more efficient, and saving and the safety and the safety aspect as well. So it's similar across the living labs. Thanks.
Yeah, good. Thank you, Pat. I'll continue here then and ask Michael another question. You talked about these connectivity issues that these trucks and farms have, and what's the biggest issue there? What is it? Same there? Is it a coverage? Is it the cost, or is it the willingness maybe of these farmers and transporters to adapt these or adopt these solutions?
I think one of the things that I've experienced from talking to these manufacturers of digital tools that they are adding to trucks and trailers for this sector is that they spend a lot of effort on developing one system, and then they are just improving perhaps the software a little bit, but it's something that you buy and then it stays on the then you just move it from truck to trailer, but you are not renewing this tool. You are keeping it for a long time. So even some of the systems they have, they are somehow pushed as long as there's a new mobile network connection, for example, going from 3G to 4G. Then they will start adding modems to their tools, their digital tool devices, also to enable 4G connection. So it's something about the next time they are gonna change this device, the modem inside this electronic device. It is important to tell these companies that there are actually new opportunities that is about to maybe on the market. So it's about training these also the hauling companies that there are actually some solutions in the future that will provide you with better connectivity in rural areas instead of giving up on these tools that can make transport and hauling and make more efficient in the future. Everybody of the hauling companies and that we have been talking to in relation to this project, they are all saying that yes, they would really like to be a lot more efficient and much better of controlling temperatures in the trailers for the goods and traceability and all these things that they believe is very important. But they are somehow sometimes they experience this with the connectivity as an issue. So they are really interesting in learning how can this be improved in the future. So and that's what we are trying to provide, or we are providing here in the COMMECT project. So our last task here in our living lab is, of course, to share this knowledge that we have from our tests and our technologies that have been put together. So yeah, it's they need to know about these possibilities for the next generation of their digital devices, electronic devices on trucks and trailers. So, but it's not something that is changed every year. It's maybe every 10 or 15 years or something like that. Yeah.
Well, thank you very much, both Michael and Per, for your presentations and for everyone attending this webinar. We will post this on our website so you can go back to it if you want, and we will also host some more webinars here coming up. So please follow us on LinkedIn to get the latest updates, and follow us these last couple of months of the project to see some of the results that we are achieving. Thank you very much. Bye-bye.
Thank you. Bye-bye.
Thank you all. Bye-bye.
Thank you very much. Bye-bye.